Hello, everyone. Welcome to our Core Devs call number 64, the last one for the year 2023. Today is December the 7th. It's around 11:06 a.m. on the Eastern Coast here in Canada. We have a number of things to cover today. The faster finality in Filecoin. We have the DRAM testing and future planning by Will Scott and Patrick, I believe. We're going to be discussing retrieval incentives, and then I believe that's an FRC aggregator deal standard. And then Jennifer will walk us through very quick updates for NV21 Watermelon updates. Without further ado, let's get started. And over to you, Marco.
So I will tell you when to click, right? This is the deal.
Yes, just let me know.
It's going to be suboptimal, but okay, fine. So the status of faster finality in Filecoin, we had a discussion that basically abated 5 weeks ago when we went to a not full redesign of the protocol, but thorough revisit of the design. And basically we posted on FIP discussion 809 latest documents that we now call for public review as of last Friday. So these are mostly 3 documents. 2 are advertised in the FIP discussion post. So any interested reader should start from F3 high-level design, and then basically it structures the discussion and then points to other documents. So the other documents are like the Gossip PBFT, which is the new name of what was Granite implementation of fast finality in Filecoin. And then we separated in a separate design doc F3 finality decision exchange subprotocol. So in the next few slides, I will just give you context on this, but the idea is that you guys go there, see the designs. The FIP is coming, so we are writing FIP as we speak, but we wanted just to publish it 2-3 weeks earlier than the actual FIP to get the feedback as soon as possible. Implementation is sort of on the way already. So Alex North has been working for several weeks on his simulator of Gossip PBFT. Jay is working on F3 finality decision first implementation, and now we are getting also Ayush from NV21 basically onboarded to have the implementation ongoing. And from Consensus Lab side, we have Matej Pavlovic, Alex Pedroza, and myself working on this. So we have a pretty large team and we are pushing hard on this. So in the next few slides, I would just like to give you some details, right? So next slide, please. Yeah, so this is like a lazy print screen from the F3 high-level design document. There are like 3 main components to the protocol. There is the loop in which the EC, when it delivers, let's say you want to finalize every epoch. So whenever you deliver a tipset locally with your Lotus miner, then you will feed this as the current canonical chain to the F3 module. And then basically F3 module would finalize this block. You will see in the following slides the illustration of this, but then in the F3 implementation, there is a tailored consensus protocol that looks like classical consensus protocol, but has additional properties, as we will discuss. And it provides the guarantees against 1/3 of adversary controlling 1/3 of QAP. And it does provide some additional guarantees beyond, right? But it provides all the properties that we list in one of the next slides. Basically, despite 33% QAP adversary. There are very few changes to EC, and this was like one of the main drivers for this design. So the only change, if you will, to EC is that EC will get informed by the F3 module of which blocks are final, and then this will basically influence the fork resolution inside EC. So basically, EC is not going to reconfigure to a fork that is not respecting the F3 decisions. So this is the only change to EC. Otherwise, EC progresses as it would. And basically, for example, if F3 halts, you would have EC progressing and doing its own thing. So let's go to the next slide to see like with illustration how this works. Yeah, so let's say that we get new blocks from the network for EC. So we are building EC chain. So F3 module sits next to EC, right? So there is a new block appended. So here the tipset is abstracted as a block. So there is new block C coming, and the last finalized block is actually G, right? So then the next click is. Yeah, so now we have this participant feeding the chain E into F3, and now F3 doesn't need to finalize necessarily C. It can finalize a prefix of C, right? So it can finalize B, and in this example, what's great is basically finalized by the F3 component. So this is B. Can we click again? So this is the change that we are proposing to EC. So here the behavior of EC needs to change. Imagine that there is what would be a reconfiguration. So this B prime, C prime, D prime. And if you just look at EC without this finality module, then the canonical chain would be D prime, C prime, B prime, G. And it cannot be, right? Because we have a finalized block in B, then the change to EC is reflected by having C, B, G still being the canonical chain in this case. So I'm highlighting just the change that EC needs to, like how EC is aware of this finality module. Can we click more? There is a proof of finality. Here we are illustrating the proof of finality by being attached to the block. So we are currently converging to basically design for F3 synchronization, which is probably going to use actors and not changes to the block header as kind of is intuited here, although this can be also depicting the changes to the actor. And this is to support basically dissemination of proofs of finality for fast catch-up as well, like not supporting only Lotus miners catching up to F3 finalized block, but also light clients and smart contracts. Can we click again? And once more. Yeah, and this continues along the way. So here basically we have, this is not the format, this is the illustration, and the exact basically specification of all these data structures is being fleshed out. If you're interested now, just a guideline for the 3 documents that I mentioned. So this high-level high-level protocol that we are seeing on this slide, this is in the F3 high-level design document. Dive into the F3 box, which is not shown yet. So this is the gossip PBFT implementation. And if you wish these boxes added to the tipsets here, this is going to be specified. This is actually specified in the F3 synchronization document. So these are the links that you have in the original slide. So you can click on all of them. And if you click on F3 high-level design, it will actually lead you to the other 2 again. Let's click again. Yep. So these are the properties of F3. So there are some classical properties that we had also 5 weeks ago. But what we added and what we like, where we spend a bulk of these 5 weeks is, if we click again, is this EC incentive compatibility. So basically, if you use off-the-shelf consensus for finalization in Filecoin, you wouldn't get this property. And then basically what we were doing is we were taking the original Granite protocol, streamlining it a bit. So like removing some unnecessary parts of it, but also adding this particular property. So this is the property that, so I have to say Alex North insisted, and I would say rightfully in retrospect on this property, which means that the participants, so the Filecoin SP will not contribute to finalizing a tips that it doesn't locally have, unless this is already a formed decision by a 2/3 majority. So there are certain cases in which it needs to do. So for example, if I don't have a tipset, I'm like Eclipse from the network, or might just, my Lotus miner is being restarted, so I don't have this block, but then I'm synchronizing with the network, and another tipset that I don't already have is actually being finalized. So I need to adopt this. There are some executions in which I need to adopt a tipset which I don't locally have. But like we have a protocol in which the node doesn't vote actively for a tipset it doesn't locally have. And this is to align with incentives, because EC incentives, because imagine that the block the tipset is finalized that a miner doesn't locally have, then it cannot continue EC mining because it needs to fetch it first, right, from the network. And this might create in a realistic model, right? So in a rational model, this may, if you just have a protocol that behaves differently, then this wouldn't be aligned with EC incentive wise. So this is like where we spend at least, I would say, 2 weeks on tailoring what was Granite protocol to have this particular property and then polishing the other ones as well. Let's click again. Yeah. Now a bit of what Granite became. So Granite became this COSI PBFT because as we were streamlining the protocol, so we started with like 5 phases protocol that was like repeating over rounds and so on. But then we streamlined it a bit, and then what emerged from the initial design is a 3-message pattern sub-protocol that looked a lot like this Castro-Liskov PBFT protocol, which is you might have heard of. This is like a 20-plus-year-old protocol, and basically invariance that our new protocol, how it maintains consistency and how it transitions possibly decided values to future rounds looks a lot like this classical PBFT protocol. Unlike classical PBFT, which is leader-based, we essentially eliminated the leader. So the communication is based on assuming gossip sub, so it's really motivated by all-to-all broadcast-based communication that DC already uses and that we are going to use. And then we adapt to the protocol to that, right? So imagine this is a version of PBFT that never uses like point-to-point messages to the leader, but always has all-to-all communication. And so it's essentially a leaderless protocol, but at certain points of the design of such a BFT finality protocol, one needs to quasi-elect the leader to basically, because this is, if you will, this is when you elect the leader, it's easier to enforce a single decision in case you have like multiple possible decisions floating around. So this is like the high level intuition, right? But we streamline this and like there is no dedicated leader, but we are using like a VRF inside the protocol to have this quasi leader election. And this is another change that we had to, if you compare to original PBFT, right? And we have this custom tailoring to Filecoin. So EC incentive compatibility and one other attack that we described in details in these design documents, and it was pointed out originally by Nikolai in Field Singapore, which we call Filecoin power leakage attack. So if you like use off-the-shelf BFT protocol, like without this custom tailoring, then any adversary that controls more than 33% of QAP, just by doing that, can mount an attack in which, by playing carefully with censoring window posts, can basically leak the power of honest miners and essentially take over the network. So we spend a lot of time on actually addressing and like countering this attack beyond 33%. So we have all the guarantees, like it works perfectly with up to 33% QAP, and then beyond it has these additional guarantees. So to conclude, slowly, we have 2 versions of the protocol, and we are like, this is let's say one of the big final decisions that we are taking on the design side is like, how do we prevent Byzantine malicious nodes from like sending some messages to basically confuse other participants? And then we call this message evidence. So in the original PBFT protocol, you piggyback these proofs to a given message, and we call this explicit message evidence. If the evidence of that the content of the messages that I'm sending you is actually that I computed it well, I'm attaching the proof to the message. So we have these in a classical PBFT, these explode. These are huge, but we managed to make proofs only in cases where everyone agrees on very same message, and this can be very efficiently implemented by BLS aggregate SIGs. And we have 2 versions of the protocol in which this compact proof is attached to the message, and one in which actually nothing is attached to the message, but gossip sub disseminates evidence in the background. So when you receive a message from me, you will say, okay, Marco is saying this, but let me wait to hear what other causally preceding messages, what the others said like, could this actually be a valid message that honest node could send? And then we have this, like, we are nailing the choice between the two down. You have a small decision table, like a coarse grain decision table here in the bottom corner. And we are picking the choice between these two. And then we can call, this is one of the last two things. The other is like some small details about F3 synchronization that we are working out. Yeah, next week. Yeah, next steps. So we are still chasing NV22. So this is, I mean, before delays of NV21, this was, you know, the code freeze is planned for January. We have the implementation ongoing, but like, you know, this is going to be very tight, but we have the strong momentum. So we are still chasing the deadlines. I don't know if like NV21 delays will impact NV22 timelines. Let's see, but like we are just working in the ASAP mode. Please comment on this. We have a Slack channel in which we really try to work in the open, so you will see a lot of action there. FIP is coming hopefully next week for sure, like before Christmas. And I would like to thank the broader team, you know, Alex North, Matej, Alex, Junior Pedroza, Jay, Ayush, and George for hard work on this one. Thanks.
Thank you so much. Considering time, are there immediate questions from anyone? No? All right, thank you so much, Marco.
Thank you.
So over to you, Will, now for DRAM testing.
Sure, this one is pretty quick, hopefully. We had this on Phil Protocol a little bit ago, but I figured it may be worth raising synchronously to have a discussion and to also sort of flag that there may be other things that we want to do at the same time or in the same frame as this. So in the lead up to Filecoin launch, we did a set of disaster recovery exercises around what happens if DRAM halts, which causes blocks to sort of get produced in Filecoin in a degraded state, and then there's a catch-up period afterwards. But also, we should be getting, you know, lots of Opsgenie alerts and phone calls, and understand that that is a bad state that we should be actively debugging. We haven't done that for 3 years. The people who are on those Opsgenie alerts is, in some cases, very out of date at this point. It may be time to run these disaster recovery exercises again. We proposed January, and the thing that seemed least disruptive is we take a butterfly net instance, we would transition it to use the Incentinet chain of DRAND, which is one that is purely operated by a set of DRAND team controlled nodes. And then we pause that and restart it at a couple different granularities. One where we can recover fully gracefully, which is the sort of more ideal state, and then a longer one where we have things down long enough that we miss some window posts. We'll need to make sure we've got some provider with deals running against that network so that we actually see that those failed posts happening and can do some of that recovery. And the thing we won't fully get here is alerting, because we won't necessarily have our production alerts set up against the butterfly net thing, but we can at least simulate what should be happening there. So that is a plan. I think we are finalizing with some of the people around Lotus and hopefully Forest as well, that the date in January is good for us to run this experiment. The I think thing to think about for anyone on this call, are there other things that were done in the lead up to the mainnet that we are getting rusty on, that we haven't done for 3 years, and that we should try and get back into our operational memory by running experiments or running recovery exercises like this one? Cool.
Thanks. I think Nicola has a comment, I believe. I actually have notes from the last disaster recovery and things we should investigate. Okay. Are there other questions? Yes, Molly.
I think Ayush was first, actually.
Okay.
Yeah, I can be quick. I'm share the sentiment in chat of good to see that this is happening. Thank you for kind of pushing on it. It occurs to me that there's kind of like almost three levels to the testing and recovery that we're talking about here. One is the DRAM software itself. What does it do in this situation? Does it, handle this gracefully and run the catch-up as intended? Level 2 is do consumers of DRAM, which for us is Filecoin clients, Lotus, Forest, Venus, etc., consume the graceful catch-up gracefully, or do they fall apart when that happens? And then level 3 is kind of the operational stuff of do we as a community deal with this well, or do we run around like headless chickens? Is that correct? And if so, have we considered / have we tried just doing the DRAM portion alone? So let's say on Sentinet, which no Filecoin network is currently using, as stage 1, and then stage 2 can be actually using a Filecoin network, Butterfly Net, which is a lightweight, low-risk one. And then perhaps stage 3 could be actually touching something like calibration net and so on. Is that possible that we consider that?
We have, and I guess I shouldn't be saying we and speaking for the DRAM team, but the DRAM team has halted and recovered beacons on QuickNet before anyone was using it fairly recently, and recently ported all of their alerting over from PL Slack to DRAM Slack, and so renewed all of the alerting pipelines in that process in the last month or so. So I think feels fairly good on that first stage. So I think this is now moving into the second stage, which is how does the downstream Filecoin implementations handle cases of DRAM outages.
Sounds good, thanks.
But I think I agree with that 3 tiers of things that we should be sort of auditing. I think maybe what I'm going to take away from that is we should try and get a checklist of the things we're trying to validate, so that we have in our heads what it is that we're looking for in doing that audit.
Yeah, the only thing I agree. The only thing I'll add is that Filecoin clients can test this independently of this is totally good exercise. We should do this, but also Filecoin clients can test this independently just by pretending DRAM is down. If speaking for Lotus, we don't have that functionality today, but it also would be relatively simple to just run an exercise where you say pretend the network doesn't exist or is being unresponsive for 2 hours, and that should give us that's kind of like unit testing just the client alone. But yeah, not something we've done for 3 years, so definitely something that's good to come on our radar.
I do think folks brought up the community response is an important part of it as well. And that's also kind of related to some of the tests we did during Space Race in terms of kind of like community preparedness to do very fast turnaround upgrades, which comes in useful if there are ever any problems from a network upgrade like that, or any quickly identified issue in the network, where I think we did a 24-hour network upgrade or something similar to simulate an emergency upgrade, which was a useful practice. I am a little worried that if we don't have enough real world data on ButterflyNet when we do this sample halting, that we won't see the full impact of it. So maybe there's a good nudge to try and get as many storage providers and real sample data that emulates real world existence on this ButterflyNet. Maybe we can clone a chunk of state or something, or maybe we start ButterflyNet effectively as a fork of something, so that we have a bunch of historical data on it somehow that we can use as part of the upgrade to see more deeply how, or sorry, not part of the upgrade, as part of the failure test, to see how those things respond in the failure test case. That could be, having a deal or sector that is supposed to terminate or expire in the exact window of the outage, could be really interesting. What happens in that circumstance where something should have ended or expired, but the network was down during that window of time. Those were things that we weren't actually able to test in the early days of space race, and could be interesting if we have enough rich data on a network as we're testing right now.
Thanks. Jennifer?
Yeah, I think Ayush and Molly covered a lot of the points I was hoping to raise. And I do want to double down. First, like, thank you for raising this exercise. It's very important for us to refresh in that. I did go back and dig into the experiment we did in space race. However, from my understanding at the time, implementations are well prepared to make sure that we know how to handle the DRAM incident, because you know it's an experiment designed for testing that. Since then, implementation has evolved over the times, and DRAM network also has changed a little bit in the time. Also, we have Venus and Forest joining the Filecoin mainnet, which were not a part of the initial testing during the space race time. So I think it's very important to have those two implementation also joining this test run as a matter of like practice, right? Not only we want to make sure each individual implementation can catch back up when the DRAM network is recovering, but also we want to make sure all the implementation will still be able to end on the same chain with the same state, not creating intentional fork when something bad happens. That's why, again, like, I appreciate DRAM team first, like, reach out to the Lotus team to perform this test. However, I do feel like we as Filecoin implementers, we should coordinate across Venus and Forest to do this together. With that being said, I do think Ayush has a very great point to, you know, decouple the stage. So I would love to hear from like Stephen or like Hubert or David. Sorry, to answer Molly's question, she is asking me whether the butterfly net include all implementations. It's an open network, everyone can join. Forest just added support last week for this testing purpose. Venus is welcome to join as well. We plan to coordinate the butterfly net for this testing across implementers. With that being said, I do think it's worth for each implementation to spend some time to first validating if they can actually handle DRAM network with their current implementation, as Ayush suggested, so that they can catch any implementation gotcha before the coordinated effort across all implementation, right? Because that will help us saving some time when we are all staying online at the same time, when we purposely kill the DRAM network and see the impact on Filecoin. And we can also decouple the potential issues that may be discovered during the testing process. So I am curious about how Forest and Venus team think about that. At least from the Lotus perspective, I am raising threads, discussing with our internal team members to see how we should be verifying how Lotus is performing first in the next couple of weeks, and see if we can have an answer before the proposed timeline here, January 8th. I'm curious how, you know, Hubert, David, or Stephen, if you are online, what's your thought on that?
Yeah, David, go ahead. I can see. Oh, Stephen.
Yeah, okay. Yeah, from Veda's point of view, I would think that yeah, this is a very good practice and very important testing to see how the implementation will react on this kind of yeah, incident. Yeah, we will, as I will discuss with the team and say, yeah, from this kind of test, we could do what kind of preparation, and also what data we could gather. Yeah, this is for from the Veda's point of view. And one thing I'm thinking is about because the Filecoin network, we already have been running the Filecoin network for more than 3 years, and we already have a lot of data, right? In the system, yeah, we are doing the testing in Butterfly net. I'm not sure if we want to have the mainnet snapshot to be imported into the network to test, because I think we want to mimic the mainnet to have all the state, perhaps where we have all this state data and power, and which could be different than a very new network. But the thing is that okay, the fake power perhaps we will experience a lot of power loss, but I think that will be okay if it's only about 30 minutes or 2 hours minutes. Yeah, it's kind of another accident of okay. Yeah, okay. Maybe there are some other concerns also, but I'm not so sure right now if this feasible to do this. But anyway, my point is that I would really want to have this contest with data there.
I think that is right, and especially if we see blocks and the chain being having any contention, making sure that the result of having things pause for a bit and then how that resolves out is going to be a set of dynamics that getting confidence in will be something that I think maybe is somewhat relieving once we finally get there. I don't know if that's something that we'll realistically have for January. Like, that just seems like a lot of work, and I wonder if we want to decouple that to a subsequent exercise, would be my only response.
Okay. Are there final thoughts on this before we move on? Otherwise, maybe we can continue to share ideas async. Okay.
I just want to say that Forest will definitely participate in this test, and we will see if we end up on the same chain and report back if anything weird happens.
Great. All right. Back to you again, Will.
All right. This is a discussion that I will also try and keep relatively brief about defining some tiers for retrieval expectations as one small step down the path of better incentivizing retrievals. And so it's sort of a combination of two things that we formatted into a FIP format. The part one is that we try to collapse a very broad space of retrievals into something that can be enumerated or referred to through a much smaller subset of common positions in what retrieval might look like. And so we try and define different categories that content may find itself in. So whether it's offline, being hot, retrieved a lot, or archival. And that by itself would probably be FRC, but it's something that I want to get a bunch of attention on. And so formatted it with the FIP in the same way that we've defined supporting formats with other FIPs. And so the thought is when we're talking about retrievability of data, is this a set of categories, or how do we want to standardize talking about that across different implementations and so forth, so that people building at higher levels are able to have clear expectations of what they're signing up for. If that varies between different implementations and different providers, it starts to be much harder to build markets in trustless ways, that everything's going to be sort of different across the different layers of the stack. And so I think standardization here probably helps us a fair amount moving forward. So that's part one. Next slide. The second FIPI part, where we're actually proposing a change in consensus, is that we would say when pieces are getting activated in a DDO world, the CNUM gets included. So as data is getting added via piece activation manifests, it's tagged with whether that data is expected to be offline, archival, or publicly available. And that then we justify by saying that what that means is now, as a client, I can go look at the active data from a provider, and based on now this visibility, I can see how much bandwidth they're signed up to serve to other clients, and I can compare that against what I can observe their bandwidth capacity looks like to understand if they actually have the bandwidth available to store my data set. Because without having that visibility across sort of the sort of state, it's much harder to understand if there's actually going to be a potential. And so if we're going to move from contracts to trustless ways to commit your data to someone, we need both sides of that, likely. That's the fifth part. Next slide. And so 3 discussion areas here that I'm sort of interested in pursuing. I don't know if we're going to really get through all of these in core devs in this one. We can maybe either schedule some subsequent discussion sessions or move this async. I'm happy with either. One is that I think in both the governance conversation and just generally where we've seen with FRCs is that FRCs, we tend to merge and not really have much discussion and not have much actual standardization upon. And so I guess I'm wondering if what the extension of, I don't know if it's core devs, but more generally implementers to have a forum where people are willing to put attention and time so that we can have discussions on things like these standards that aren't necessarily consensus layer. Because I think the FRC process as it is right now is not getting enough eyes to be to be valuable and to do things in that format alone. And so that seems like a bug that we should be iterating on. And so I wonder if that is collapse it in the way that I'm doing in this one, or if there are other suggestions for how we assemble the right people and build that governance layer past the consensus layer. I think the main pushback we've gotten, and forgive me for people who've commented on this FIP so far if I'm not characterizing this. But generally, I think there's a pretty reasonable argument that a lot of this market stuff ends up a layer above the consensus layer, right? That this is a thing that we want some diversity on, and so we should be solving this at higher levels. And I think that's probably the main discussion point that I'd like to then think about what we should be doing as a protocol layer. And as a network to get to reliable and broadly available retrievals, which I think generally agree is going to be a large value unlock for Filecoin. I think we've had this as a thing that is possible at higher levels for the last couple of years, and we've seen relatively little movement there. And so I guess the sort of open question to challenge all of you with is, what is it that we can be doing to help accelerate higher levels of the stack around retrievals? I will leave it there.
Are suggestions or questions or ideas around this?
My understanding, Will, is that the current approach is mostly an FRC-like approach that involves an implementation of that FRC in the general, like the currently used markets implementation. Again, other markets wouldn't necessarily have to implement that FRC in an FRC-like approach. However, the benefit of utilizing that is that we can then add auditing to the protocol for whether or not the retrieval levels as specified in a deal are being upheld through something, say, like the station Spark retrieval checker bots. And we instead go from a place where every client has to directly monitor that and implement any monitoring themselves with their own understanding of what retrieval expectations they've said. The protocol can now do that for them, which means we can collectively report on and talk about our compliance to retrieval guarantees at a market implementation level instead of on a per client level. Am I summarizing correctly? Any caveats?
So I think that is sort of the question is like, how far down do we want to standardize? Because the lower we standardize there, the less sort of re-implementation we're asking for in some sense, right? So that could be market level, that could be DDO across all the markets level. So are you going to also have a standardization even for other market implementations? Or is that one where each market becomes its own little bubble, but you don't know how much capacity the providers have potentially implemented in other markets that they're also supporting?
Which might be okay, right? If it's even if
they may well have things outside
bubbles.
of Filecoin as well, right? And so you can't necessarily know that overall capacity that you can measure is going to be reflective of what becomes available or what percentage is used by the Filecoin that's visible.
Yeah, it from my vantage point, to not require it at a market level, but I guess how would that fit with DDO, I guess, in the context where there is no market deal, but it is going through something like the Phil Plus registry, it's not using the current markets, but Phil Plus registry, would we then add it to the Phil Plus registry implement as well?
My proposal was we added it to provider sector activations, which do still exist in DDO world. Which, so when data is sort of being added to start being window posted, the provider would also be tagging it with how much retrieval is expected of that data that they're now adding. That would be the below markets one. So that's going all the way. And I think now we get to negotiate up how high up the stack do we think is the right appropriate level.
Great.
I mean, in a world in which DDO lands, we would want, and a chunk of folks choose to utilize just the registry for the gas savings of not having to use the markets implementation, but they're registering their deals in the Phil Plus registry. I think we would want this information because it is a core part for the Phil Plus registry data as well, to be able to talk about its retrievability guarantees. So that's, I think, from my vantage point, something that triggers at that level is the highest I think we'd be willing to go. It's maybe possible to do something that's at that level and not at the lowest layer that you're describing. But maybe just to bound the conversation with those options.
I've made a lot of comments on the discussion thread for it. I think that's the best place to continue here. But yeah, since the discussion worked its way around to here anyway, so yeah, I think it would be relatively reasonable for something like this to be added to the Phil Plus registry if that's what the Phil Plus program is going to do. Like that's still we're still talking about who can get QAP here, so it's still a deep protocol change to do anything there. But you're more, I don't think more flexibility or more expressiveness in Phil Plus allocations is unreasonable. I think it's a reasonable for us to add some dimensions of metadata there that the program can use can use as policy, which will eventually feed into QAP. But I don't think it's reasonable to require this to be specified for any data that's stored anywhere in a sector across the whole network. Even sparkling data, as we say, not necessarily associated with what we might call a deal. But then I do totally agree that any kind of market should be able to express things like this. Whether or not we should standardize on different ways of doing that, I don't know. I would err towards no until we have a bunch of markets doing things and we can learn from variation. But I wouldn't want to get in the way of that. But DDO has enough pass-through information to allow markets to express any kind of policy that they want for that without us changing anything in the consensus protocol or requiring a market to do something like that.
Thanks, Alex. I have to hijack the conversation now. Seeing that we have just about 9 minutes or thereabouts to go, we can continue the conversations, Will, offline. Adi, I think it's now your turn.
Awesome. Yeah, do you mind refreshing the page? I just added a bunch of stuff to the slide.
Okay, 1 second. Let me do
Thank
that
you.
quickly.
On the retrieval question, actually, like, I guess one question that comes up, and maybe there's something that has been covered elsewhere in another forum, but is there still an active discussion or thread about tying retrieval incentives to block rewards or resurrecting in some capacity retrieval.org? Or has that broadly?
So I haven't heard the retrieve.org one super recently, but that is an experiment that exists. In terms of block rewards, I think as we see evolutions of the allocator pathways in Phil Plus, we may see some allocator pathways that include expectations on retrieval or things around retrieval as part of their structure for their allocator. And so that can then evolve into more incentives for retrievability of data.
Got it. Okay, cool. Yeah, happy to just continue basically discussion. This definitely has implications in FVM as well. So yeah, I'm here to basically talk about FRC 70, which is the aggregator deal standard that we're proposing. We're defining a family of interfaces to facilitate aggregation on FVM and IPC. This has no impacts. This specific particular FRC has no impacts on core protocol work. It's entirely a userland FRC. And so, as Alex talks about in the discussion, just let 1,000 flowers bloom here. This is something we're particularly excited by because we're actively building this FRC with Spheron, Lighthouse, and more recently in threads with Nicola and Deep to provide prototype and deploy aggregation flows that leverage this FRC. We have an initial implementation that also walks through this. The broad purpose of this FRC is to allow trustless aggregation with entities that have historically required trusted aggregation flows, specifically through a submit complete callback loop, essentially where a user, a client can call a submit function on a smart contract that implements FRC 70, triggers data aggregation, aggregates a bundle, and the aggregator can call back call back this complete function, which contains the inclusion proof to allow trustless bundling of different small bits of data into a larger storage deal. This hopefully serves as a primitive that enables interaction with other on-chain entities like data DAOs and dApps that want to use FVM to facilitate storage of information on Filecoin, and also enables use cases around the persistence and the maintenance of small data on Filecoin. We have obviously a lot more in the discussion threads and the FRC and the PR, so if you're to have a look there. But yeah, this is kind of the 10,000 foot view, and would love to have questions or comments in the time we have left. Short and sweet, but there's much more if you click through the links.
Thank you. We can take some questions if we have any. I believe this is the last main presentation for today's call. Okay, doesn't appear to, we don't have any hand up. Okay, thank you so much. I will pass this to Jennifer now. You can do like a quick, updates or anything you want to share about the Watermelon upgrade.
The upgrade is finally coming next week, December the 12th, 4 days away, around 1:30 p.m. UTC, I believe. all implementations, Lotus, Florist, and Venus have published our final releases that's supporting this upgrade. So for any node operators, if you haven't updated your node just yet, please do so. This FIP does including a lot of new features like synthetic pull wrap that we're hoping storage providers and CDN service providers can leverage off. And a good news to the data client or application builders who want to store data on Filecoin longer, that we are increasing the maximal sector commitment and also the maximal deal duration from 1.5 years to 3.5 years within this upgrade. If you have any combining this along with the changes introduced by FIP 45, basically data clients can store their data across 3.5 years to up to 5 years if they have data cap, just like with Filecoin protocol today, and they can use different perpetual storage solutions on top of FVM so that their data can store longer in the network. We have a lot of FVM fixes and enhancement in this upgrade as well. I do want to call out that some partners has flagged that they're observing some gas usage increase in the multi-sig operations after running some tests with some of the changes. If you are observing the same, they are likely from the FIP 61, where we are adding some additional charges so that we can make sure that the state access is deterministic. If you have any concerns on that, please reach out to us in the FVM dev channel in the Filecoin Slack. We are happy to answer any questions that you might have. Also, as a call out for this particular upgrade, we are expecting a heavier than normal state migration upon the upgrade, as we are migrating all the sector information so that we can fix a sector activation epoch bug that is overridden by replica update today. Lotus and Forest has done some benchmarks on how long the migration are taken. Depend on your hardware and how much disk and memory you are heavy, you may expect a 5 to 10 minutes pre-migration. I think it's 5 to 20 minutes migration if we are just running a regular day-to-day node for this upgrade. We are not expecting any network disruption because of that. However, if you're running a full archival node, has all the historical data since Genesis, you may have a heavier migration to perform compared to a day-to-day node. So please do check out with your implementation and the team to see how you should be handling and set up your node to migrate, to make sure that your node migrates smoothly under this upgrade. For example, in Lotus, there's an environment variable you can set to increase the number of the workers to be running migration in parallel across the upgrade, and that can help with your memory consumptions a lot if you are holding a larger amount of the historical state. I think yes, Forest has a better performance because their implementation and all things like that. So basically my call here is check with your implementations to make sure you are ready for this upgrade. I think that's it, but also I want to give a call out to the Forest implementation. If you haven't checked out their implementation, please do so. And now they're supporting Filecoin mainnet in production fully. They do have some advantages of being a client implementation, depend on what your use case is. If you are just running a node to interacting with chain state and so interacting with chain or building block explorers and so on and so forth, or you are hoping to run full archival node, I would highly suggest you to check out Forest implementation. They offer a lot of the features or improvement that Lotus doesn't currently offer. So please check it out. Also, if you haven't noticed, Forest is also offering a snapshot service That's again fully backed up by Forest node. The link can be found on Filecoin documentation side. If you can try it out and use that as a backup to the snapshot service that's backed up by the Lotus node. That can help you add resilience on your node maintenance and so on and so forth. But yeah, that's it. Thank you.
Thank you so much. Thank you everyone for joining. Apologies for the confusion with the links and joining. We'll take a look at that and make sure it doesn't happen again. Otherwise, see you all next year. Bye.